Hello, my name is Javier Torres, and I'm a developer advocate with IBM. Today, I'll be taking you through the hands-on lab for machine learning, where we're going to evaluate a machine learning model for bias. More generically, we're going to see how we can build trust in AI. A little bit of logistics before we get started. So on your screen, you should see two links. The first link, ibm.biz/ddc-wos. This is the lab instructions that we will follow today. So it is a Git book with all the step-by-step instructions we will follow. Now, I will be running the lab live, but if for any reason you want to take your time, read through it more, or maybe I go too fast, don't worry, the instructions are there for you to follow along. The second link, ibm.biz/ddc/Slack. We have a group of folks available to help you. So if you have questions, if you have issues as you're running the lab, please ask questions on the platform as well as on Slack. We also have language-specific channels on Slack if you want to ask questions in your local language. So for now, go ahead and open up that first link. Now that should bring you to a page like this, the one on my left-hand side. And what you will see is this is the actual Git book that we're going to be using. So a little bit of context before we get started. So throughout the morning sessions, you've heard a lot about the importance of AI, the importance of building trust in AI. Now, trust in AI is important for a couple of reasons. First, so that we can see more models go from development to production. Data scientists, developers, people using those models need to have trust in them. The second is, as these models go into production, we are seeing an increasing number of regulations around how you use those models and how you report on those models. So trust in AI is very important. Generally, when we talk about trust in AI, we mean a couple of things. It's built on a couple of pillars. So first, it's that we have an ability to know that the model is fair and unbiased in its predictions. Second, it's that it's transparent. So I have some amount of traceability. I can go see how that model arrived at its prediction. And then third, it's that it's robust, right? So I have a way of knowing or monitoring that this model that was trained at one point in time is still performing in the way I would expect it. So over the next hour, what we're going to see is how we can use the monitoring and managing capabilities of Watson OpenScale to start to build out that trust and transparency in AI. In terms of the scenario we're going to use, so what you see here in this picture is we're going to be focusing on credit lending. So if you think about the scenario of credit lending, you have credit lenders that obviously they want to increase the loans that they make, the number of loans that they make for their business. As they're doing that, they're obviously wanting to reduce the amount of risk they take. So they don't just want to hand out loans to everybody. And they also have to comply with regulations. So what that means is that credit lenders are turning to a wider data set. So they are going to look at loan applicants and start to see, for a loan applicant, start to look at their age, their employment history, their FICO score, do they have a checking account, all these different data points so that they can build a machine learning model that will essentially predict if this loan applicant represents risk or no risk for them, and use that model prediction in their decision-making process. So they're building out this credit model. And what we're going to see in the lab today is essentially how we can create that model. So first, taking a model and actually deploying it to a runtime environment. We're also going to see how we can monitor the performance of that model, so how it behaves operationally over time. And then we're going to start to look at some different aspects or qualities of the model. So how it performs from a traditional data science quality perspective, if we can identify how fair the model is, if we can understand how the model arrives at its decisions, and then finally to track the robustness of the model. So if you go down here, as you go through these Git books, anytime you see this icon, that's just going on to the next page or the next step. So let's go ahead and get started. And let's talk about our lab environment setup. So a couple of things here. For the lab today, you see this diagram up top. We're going to be using a couple of different Watson services. So you are the user in this diagram. I am the user. I'll guide you through this as well. We're going to be using Watson Studio, which is kind of our data science development environment, if you will. Within Watson Studio, we're going to be using Jupyter Notebooks. And from these Jupyter Notebooks, what I'm going to do is I'm going to use Python to build a machine learning model, then use a Python client to interact with my machine learning service, which is where I will deploy my model so that I have a runtime endpoint for inferencing. And then also from the Jupyter Notebook, you will interact with Watson OpenScale, again via Python client, so you can have the Watson OpenScale service see and understand the Watson machine learning service and monitor the models that are deployed, specifically the credit risk model that we're going to build and deploy. The one thing I do want to mention is that this is the topology we're going to use for the lab. It is by no means a requirement in the sense that OpenScale, as the name says, is an open platform. So if you decide later on that you want to build your models locally, that you want to host them in your own custom serving environment or on another cloud provider serving environment, by all means, go ahead. If you want to use different libraries than the one we're going to use today, by all means, go ahead. OpenScale will still be able to integrate and help you operationalize your machine learning models. All right, so let's get started here. So if you click on the next link, which is Cloud Services and Keys, we're going to start to provision our environment. So go ahead and follow with me along these steps. The first thing we're going to do, and I'll shrink this a little bit so you can see both pages, is I'm going to bring up my IBM Cloud dashboard, which is where I'll provision my services. And if you click on that first link, IBM Cloud, you'll see that you get dropped into the dashboard page once you log in. And from this dashboard page, what I want to do is start provisioning services. So I'll go up here and click Create Resource. And that button brings me to my catalog. These are all the services that are available to you. What you'll see excuse me, is that I've got a filter here, so it's showing you the services that are available with a light plan, meaning services I can provision that won't incur any charges. So go down here, follow the instructions, and it'll tell you to further filter down by clicking the AI category on the left. And then scroll down. The first service we want to provision is Watson Studio. So click on Watson Studio. And a couple of things. Make sure that your service is provisioned in the Dallas region. I'll talk about this as we go through the labs. But for now, just make sure it's in the Dallas region and leave the plan as light. And then go ahead and click Create. Okay, so as soon as that's done, we will go ahead and click and create our next service. So in order to actually use Watson Studio, we need a place to store the assets that we're going to create and use. So we need a storage layer. If you can do this one of two ways. You can go back to your resource list and click the same Create button, or you can click Catalog up here. From the catalog, this time what I'm going to do is I'm going to select Storage, Object Storage. That's going to be essentially my hard disk in the cloud, where I'm going to store all my Watson Studio assets. Similar to before, just make sure that you leave the light plan selected, or selected if it's not, and click the Create button. And once that creates, it'll drop you back over to the page for object storage. So let's keep going. So at this point we have Studio and we have a place to store our Studio assets. So the next thing we're going to do is provision our OpenScale service, and that's this section here. So OpenScale, like I said, it's the service or offering that's actually going to monitor and manage our model. So again, click into Catalog, filter down to AI, and this time scroll down and find the service called OpenScale. And there it is. Click on that one. Once again, make sure it's in Dallas, make sure it's the light plan, and click Create. As that's happening, I'll scroll down here in my Git book. The next service we're going to create is our Watson Machine Learning service. So again, either if you click on into your dashboard and your Create Resource button, or you go up here to the catalog, just go down, filter on AI, and this time scroll down to where you see Machine Learning. So this is the service where we're actually going to deploy our machine learning model and where we're going to actually submit scoring requests to. Make sure it's in Dallas, make sure it's the light plan, and click Create. So, as I mentioned earlier in the topology diagram, we're going to be interacting with the service programmatically. So we're going to use Python code to deploy our model. In order to do that, we need to set up a set of service credentials, excuse me, so that the Python code, so that the machine learning service can know that, our code is authorized and authenticated to actually deploy models. So click on Service Credentials, and then click this button that says New Credentials. And then finally, it doesn't matter, you can leave the defaults, click Add. And then if you expand this View Credentials option, there's a little icon here to copy these. So go ahead and copy these and paste them over somewhere so that you can use them later in the lab. The only thing that really matters here is that we have an API key, and then we have an endpoint that we're going to use. So this is how our code is going to know how to talk to the service and that we're allowed to essentially deploy models. All right, so that's the last service we're provisioned. The other way that I mentioned, we're also going to programmatically interact with OpenScale. And in order to do that, kind of analogous to what we did here with service credentials, we're going to set up an API key so that we can go and figure out where our OpenScale service is and interact with it. The way we set up an API key is go ahead and click up here under Manage, and then you'll see this option, Access IAM. And then finally on the left, you'll see it says IBM Cloud API Key. Click there, and then you'll have this button to create an IBM Cloud API Key. Click that, give it any name you like, click the Create button. Now here's an important part. You won't have access to this key once you close this pop-up window here. So you can either download it or copy it. I'll just copy this and paste this. We're going to be using this key later in our Jupyter notebooks. Okay. So with that, our environment is essentially ready to go, our lab environment. So go ahead and click down here into Project Setup. So within Watson Studio, when we're actually developing a solution, we are going to work within a construct that we call a project. And a project is essentially just a container for the assets that encompass our solution. So whether that's notebooks, whether that's configuration on how to get to data, whether that's metadata, the models themselves, that all resides within the project. For the purposes of this lab today, we've pre-created a project for you with the Jupyter notebooks that you'll need. So if you see here, there's a link to download that project zip file. Go ahead and download it. I will say you don't need to expand it, just leave the zip file as is. We're going to import that directly into Watson Studio. Once you've downloaded it, go ahead and open your Watson Studio page. There's two ways you can do this. You can copy and paste that link or if you're on the IBM Cloud dashboard, you can find your Watson Studio instance. So here you see the one I provisioned. And then you can click Get Started. It'll open the UI. Now, Watson Studio, it's a full kind of data science platform, if you will. So you can do everything from, defining data that you need, doing data wrangling, data munging, building models, deploying the models, building visualization, etc. For our purposes, we're just going to use it to essentially build our model and deploy our model. So once you log into, once you open this Watson Studio page, you'd see the next instruction is to actually create the project. So click that Create Project button. And this time we have two options. You can either create an empty one, so kind of blank slate, if you will. Or in our case, we're going to create a project from a sample or a file. In this case, the zip file that you downloaded. So go ahead and browse to the zip file. Here you see I have my OpenScale lab.zip. Click Open. And then you can give this any name you like, OpenScale Workshop. And you see you have some options. So the other things you can do within a studio with projects is you can collaborate with people, right? So you might have data scientists, you might have developers, you might have business analysts, etc. For now, we're just going to leave it as the default. So just give it a name and point it to the zip file you downloaded. And then click Create. So what it's doing now is it's going to take that zip file, import all the assets, and you'll be able to see them in a second here. Okay. So as this is going, next step you'll see, I'll just move down here, is I can view my new project. Go ahead and click that button. I'll just give you a quick overview of what you're going to see here. So the project, like I said, it's got a bunch of assets for you. You can click on the top little Assets tab. You see we have a bunch of Jupyter notebooks for you. We're going to run through them using the instructions. But then the other things you can set up, there's environments. So we're going to use a couple different environments specifically around Python. You can set up deployments, you can set up recurring jobs or cron jobs, and you can set up access control based on who's collaborating with you in your project. So at this point, we've got our project. We're in Watson Studio. We're essentially ready to go and start actually doing the work of building our model and deploying it. So go ahead in your Git book here and click Deploy Model and Configure. That's the next step where we're actually going to start working. Now, a couple of things that I did want to mention. One is the model that we're going to build. So we're going to build out this credit risk classification model. It's essentially a binary model. So it's going to predict whether a label is risk or no risk. So given a whole bunch of loan applicant data, the model will say, okay, risk with a certain confidence or no risk with a certain confidence. We've specifically chosen to have this be a Spark ML-based model. Like I said earlier, doesn't have to be. We have a couple of other notebooks in here for your reference. If you wanted to build this in Scikit, we have an example there that you can follow. Builds a very similar model, different library, different algorithm, but we can still connect them. So what we're going to do here is, if you're in your Watson Studio page, you have a notebook that is called one deploy Spark model WAS configuration. In my case, it's the last one. Your ordering may be different. But look for the one that says one-deploy Spark model-WOS configuration and click on that one. Now, when this opens up, you'll see that you have essentially a read-only copy of the notebook. There is a little pencil icon at the top. Click on that pencil icon, and what that does is it'll actually kick off and start the Jupyter kernel. Since this is a Spark ML model, we need this to have a Spark environment. So it's going to start a Spark environment or Python with Spark environment for us. It might take a little bit of time. So we'll be a little bit patient here and wait for the kernel to start up. So as soon as this is started, you see a couple of things here. So if this is the first time you're looking at a Jupyter notebook, it's a very popular, great tool. It allows you to combine essentially code with Markdown all in a single page. So through one page, I can execute code and kind of get instructions. We've tried to include as much Markdown as we can to kind of tell you what's going to happen in the cells. So you'll see these top cells are Markdown, and anywhere you see this kind of gray background, that's a code cell. The way that we execute or run a notebook is you click on a cell, and then you can click the run button up here. Hopefully you see that with my mouse. Or if you have a keyboard shortcut set up, you just run your keyboard shortcut. For me, it's Shift Enter. So let's go ahead and run our first cell. The other thing to note, again, if you're your first time here using Jupyter Notebooks, is anytime a cell is executing, you will have seen a little asterisk. And let me try to make that a little bit bigger for everybody. Once it's done executing, you see a number. So the first cell we ran is our Spark validation. Make sure that we have a Spark environment since we're building a Spark model. Next thing we'll do is we'll set up some dependencies. I mentioned earlier we're using Python clients to interact with both our machine learning service and our OpenScale service. So we're going to install those libraries. Now, as that's running, you see the asterisk. What I'll have you do is go back to where you copied your credentials. And I'm going to copy my Watson Machine Learning Service credentials. And while it's executing, I'll come in here and paste those over. So there's my credentials for machine learning. And then do the same for your Cloud API key. Okay. We're almost done here installing the libraries. As that's going, I'll kind of skip a little bit ahead and kind of explain what the cells are doing. So the first one is the dependencies, like I said, installing the libraries. The second two are where we have our service credentials, so just initializing variables, essentially. This next one, model parameters. So this is how we're going to know where the name of our model once we build it and deploy it. So it'll make it easy for us to go find it once we've built it and deployed it. You can change these names if you want to. You just have to be consistent across this notebook and the other ones we'll use later on. Okay, that's still going, so let's keep explaining here. So the other thing that we'll do is we're going to get training data, right? So anytime you build a machine learning model, you need training data. We're building a supervised model. So we're going to go ahead and download our training data. It's available on GitHub. You can see it here. You can explore it if you want to. Okay. And let me go back. Since it finished executing, I'll go back and we'll just execute these cells. So again, click the cell, click the run button or Shift Enter. And you'd see these other ones are fairly quick because they're just initializing variables. So we'll keep going to where we were. And again, this is where we were. We were talking about how it's going to download the training data. It's going to tell you a little bit about the training data. In an actual data science project, you'd obviously do a lot more data exploration. For our purposes in this lab, we're just going to tell you essentially that there's roughly 5,000 records. So we're going to train against 5,000 records. And that there's 21 columns. In our case, there's 20 features and one label column. So if you look at this, our 5,000, the data set is essentially, or the features that we're going to look at, whether the checking status of the loan applicant, the employment duration, how long the person's been employed, the age of the person, the gender of the person is in here, et cetera, et cetera. All right, so that's our data. That's our training data. And I've got a cell here commented out. If you wanted to visualize the data set, you could do that kind of on your own time. So once I've got my training data, we're going to take a quick shortcut here, which is instead of building the model, which is the process of kind of transforming your data, doing string indexers so that you can go from categoricals and encode those, we're going to use a pre-built model. Now, one of the Jupyter notebooks that was in the project has the actual random forest classifier that we built here. So you can go look at that if you want to. just to speed things along here, you see that we're downloading essentially a tarball, which is our credit risk model, which is what I'm highlighting there. Once we've downloaded this tarball, it has our SparkML pipeline and our model. So we will just use that as our machine learning model. Okay, so as soon as this is done, we'll essentially have a model that we can use, which is great. That kind of gets us to the first step. We've got our model. Doesn't do us much good until we actually use the model. So we'll give this a second to finish generating our pipeline. Okay, and then the next thing we'll do is we've got the model essentially in memory. We want to go ahead and publish it. So this is where we're going to go from, the model's built. Now we need to push it to the Watson machine learning service. So we have somewhere we can actually do inferencing. So we can, take a new loan applicant, feed it to the model, and get a prediction. So that's all there that you just saw me execute. It initializes our Python client. And then we have some kind of cleanup code here. It will look, based on the name that we initialized earlier for the model, it will look to see if you've already got it deployed. If you have it deployed by some chance, it'll remove it. If you're just running this for the first time, you'd see output similar to mine here, which is essentially we've got nothing deployed on our machine learning service. The next thing we'll do is we'll define some information about our model. So essentially, it's a binary classification model, the name that we defined earlier, a reference to our training data, I'll talk about this later, and this evaluation metric for the purposes of this lab. You can kind of ignore that. That's if you wanted to set up kind of continuous learning. All right. So once we've got these parameters around metadata for our model, this next piece, specifically this command here, will go ahead and store our model from in-memory to the machine learning service. So we'll let that execute. And as that's going, I'll explain the next cell here. So it's still storing the model. Once we've stored the model, you can see that output here. We've got our Spark German risk model, so that's our credit risk model that we just essentially downloaded and imported. We've got it on our machine learning service. We can now go ahead and deploy the model. So deploying in this case is essentially what gives me an endpoint to call, right? So if I want to call this thing in real time, whenever I get a new loan applicant, I want to be able to call the model with the features or the data for that loan applicant and get the prediction. So that's what this deployment does. You'd see down here, I not only get an ID for the deployment, but the most important thing, I get an endpoint. I get a URL I can call, which is where I can make inferences, where I can get real-time predictions. And then we'll go ahead and test it. So we're just going to submit some, you see some dummy data here. So this is one loan applicant example. They've got no checking. This is a female. And you can see the rest of the details here around that loan applicant. Submit that to our scoring endpoint, and you'd see in this case, this applicant is predicted to represent no risk. So great, we've accomplished the first task. We've built the model and we've deployed the model, and for the purposes of the lab, let's say this is now in production. So the next thing we're going to do is actually configure OpenScale. So now we're going to actually try to build out that monitoring and management capability. So first thing we'll do here, we'll use our Cloud API key. It's going to go figure out, what the instance, where your instance is, the one that you created earlier. And you'd see here, that's my instance ID if you want to look that up. That's the one we provisioned earlier. And then it creates a Python client for it. Now there's a couple of things that we need to do in configuring and setting up OpenScale. The first thing we need to do is set up essentially a data mart, right? So OpenScale is going to need to know about your machine learning service. It's going, if you think about what we want to do, we wanted to be able to monitor that model, right? So what does monitoring mean? I need Watson OpenScale to know, here is the data that model is getting. Here are the requests that the model is getting. That's one thing, right? That's the payload or the requests that are being sent. I also need to have OpenScale understand feedback data, right? So periodically somebody's going to come in and label some of these predictions so that we can know whether the model is performing well or not. So I need to have the ability to store that feedback data. And then the third thing we want to do is have all these metrics that we're going to calculate, right? So how well the model is performing, is it fair, is it not fair? All these metrics that we're going to calculate, that all lives within the data mart. Now there's a couple of different options. You can have this data mart be, a Postgres database somewhere else. You can have a DB2 database somewhere else. For the purposes of the lab, OpenScale does have an internal database. That's what we're going to use, so we don't have to provision another database. So you'll see here, I'm going to go and tell it to keep the internal Postgres. And then the command I care about here is it's going to set up that data mart. Okay, so again, keep executing through that. And then at this point, the internal data mart is configured. So the next thing we need to do is actually bind the machine learning service where my model is deployed and the OpenScale instance or service. So that's what I'll do next. And then what you see once I do that is OpenScale is now able to query the machine learning service. So from OpenScale, I could tell it, show me all the models that are deployed, and that's how we can track, okay, you've got X number of models, you're monitoring or managing this model, not this model, etc. In our case, we see that the available assets, we've got one model, and in this case, you see here it says false. We're currently not subscribed, or for all intents and purposes, we're not monitoring and managing this model. So let's go ahead and actually set up our subscription. So for OpenScale, a subscription is essentially how we encapsulate all the things that we're going to monitor for the model. So let's go ahead and execute that. And within the subscription, we set up some metadata. So if you look closely here, the cell is essentially saying that we are adding a Watson machine learning asset, because that's the model serve engine we're using. It's a binary classification problem, so risk, no risk. It's using structured data, obviously. Our label column is risk. And then we're telling it, it's a Spark ML model, so the output is going to have a predicted label. That's where our prediction is. We also want it to have the probabilities of the prediction. And then we're telling it things around which ones were the feature columns. So in our case, we used all 20 columns, so you see them all listed there. And we're telling it which ones were the categorical columns, so which ones we had to encode. So go ahead, run that cell, and that sets up the subscription for you. All right. And now if we run the same code we did earlier, you'd see that, again, we have the available assets, which is our risk model. And this time it's saying our subscription is set to true. So we're ready to have OpenScale monitor the model. The one thing that we're going to have to do is we're going to have to come in here and we're going to submit some payload data. So go ahead and run that cell. And what this is doing is essentially we're going to submit requests from our client in this case to the Watson machine learning service, right? So we're going to have the model start to make predictions. Why is that necessary? So OpenScale needs to capture essentially the schema or the information about the model. Submitting scoring requests is one way that we do that. I also mentioned earlier that we're deploying these both in Dallas for a reason. One of the things that we're going to get in this topology is that machine learning service will automatically tell OpenScale when it receives new requests. So in this case, if you count these out, you'd see I submitted 8 scoring requests. And in this case, I'm showing you the first one was no risk. But really what I care about is not only did I get the responses, but now OpenScale also knows about it, right? So you see here, It's showing me the payload logging table within my data mart, and I've got 8 scoring requests that now OpenScale knows about as well. Okay, so if you've completed through that point, we've got our model set up. It makes predictions at runtime, and we've set up OpenScale so that it knows about the machine learning service and about this specific model that we just created and deployed. We've even gone ahead and actually sent some scoring requests to the model, and we see that they're getting to OpenScale. So go back to your Git book. And then the next thing we're going to do is we're actually going to explore, what does this look like from the OpenScale perspective. All right, so 2 ways you can do this again, just like you did with Watson Studio. I have a link here. If you want, copy that link. Or otherwise, you can go back to your cloud dashboard, go to your resource list like you did before, click OpenScale, and then click Launch Application. Let me close out that tab. All right, so the OpenScale service not only comes with the Python client that you can interact with, it comes with REST APIs that you can invoke, but it comes with a dashboard essentially, or a UI that you can use. And the notion here is it's not just data scientists and developers that want to understand how the model is performing. Line of business owners that wanted to create this model in the first place also have an interest in knowing how it's performing. So different roles can come into the OpenScale dashboard, and you see we have a couple of things. I'll come back to application monitors at the end. For now, click on model monitors. So this is the models that OpenScale knows about. In our case, you see we have one tile here. This is the model that we've deployed. We configured a subscription for, and you can click on that. And you'd see a couple things, right? Out of the box, without doing much of anything, since we have that automatic payload logging capability, I get to understand throughput. So my very first piece of insight. I'd see here that I can click there into this UI, and it'll show me, OpenScale knows about these 8 transactions that the model has received. And it'll obviously show you what the predictions were, et cetera. But more importantly, it can start to show you kind of the operational characteristics. So this model's throughput, right? We've only run 8 requests, so we're not seeing a lot in the dashboard, but you can imagine for a real production model, you would start to see how the model is actually performing. The other nice thing that you get kind of out of the box is you have these analytical capabilities. So the one I'll just highlight here, and you'll see this in your Git book also, is if you click on predictions by confidence, I get to see this distribution of confidence, right? So across those 8 requests, this is the distribution of the confidence in those predictions. So in this case, we didn't make a lot of risk predictions. We've only made 1, and I guess the other 7 were no risk. But I can also see, some of them have a different, confidence. So there's 1 no risk in this interval, there's 2 no risk in this interval, et cetera. Once you start to push more data through the model, you'll see this becomes more insightful, and we'll see that towards the end of the lab. So that's the first piece, right? So at this point, I've got my model, I've deployed my model, I've subscribed OpenScale to that model, and I can see some information kind of out of the box without doing much of anything, specifically around the throughput, the operational characteristics, and the distribution of the confidence. So let's move on. If you go to your Git book, the next task we're going to do is actually start to really monitor that model. So, in terms of OpenScale and the things that we wanted to monitor, what I mentioned at the beginning of the lab that we're going to monitor, OpenScale has the ability to capture a couple different things. So one is fairness, right? So have OpenScale monitor that model for making unbiased predictions, or trigger an alert when it thinks that the model is behaving in some kind of biased manner. So that's fairness. Quality. So we saw some metrics here around throughput. That's more operational. we also care about the quality of the model from a more kind of traditional data science metrics, right? So what kind of accuracy am I getting in this model? What's my F1 score, et cetera, my more traditional data science performance metrics, so that I can track those over time. Next is drift, and we'll go through each of these individually. So drift is this notion of how resilient or robust is my model. When I trained it at one point in time, is it still performing to what I expected when I trained it? Is it still receiving the same type of data as when I trained it? Or has it drifted? So the ability to monitor that drift and then create a trigger when we're seeing too much drift. And then the last one is the ability to configure explainability. So this is more along the lines of that transparency, right? So how can I have some insight into how this model made a prediction? All right. And just in terms of kind of level setting on, not terminology, but what data sets we'll use. So you're going to see a couple of things, right? So you already saw kind of in the initial setup that OpenScale is looking at transaction data. So I called this payload data before, or scoring request. It's essentially one type of data set it's looking at is the loan applicants or loan applications it's receiving at runtime. I mentioned earlier that we also want to capture feedback data. So this is the kind of somebody went and labeled the predictions to help us determine if the model is accurate or not. And then the third is training data. So I have it listed here as optional. One of the things we'll see when we configure these different monitors is OpenScale needs to know about the training data so that we can know about the distribution of the data and use that to kind of guide our monitors and be able to fully utilize fairness and drift, et cetera. And I'll go through those independently. So go ahead and click down to quality and explainability. This is the first monitor that we're going to enable. And we're going to, again, do this one programmatically. So what you'll do is go back to Watson Studio. A couple different ways. You see up here we have this little kind of navigator. Go back and click on your project. And this time we're going to open the Jupyter notebook called Quality Explainability Monitors. So just like we did before, click on it, opens read-only, click the pencil icon to actually start up the kernel. In this case, we're not using Spark anymore, so it should be a little bit quicker. It's just a traditional Python 3.6 environment. As that starts up, we're going to, like we did before, copy and paste our credentials. So go ahead and start getting ready to copy your credentials. Okay. And like I did before, I'm going to start executing the cell so I can start installing dependencies. As it's doing that, I'll update my credentials. So there goes my Cloud API key. Next up, here are my credentials for the Watson Machine Learning Service. And by the time I did that, you'd see that I finished installing my two dependencies, which are the machine learning and OpenScale Python clients. So go ahead and go through, execute the cells. One of the common things we do see if you run into issues is sometimes we forget to execute a cell. So if you see errors, just make sure you've executed through the cells kind of in the sequence that they're listed. All right, so here again, like before, we have our model name and deployment name. This lets us find our deployed model. And we're going to go ahead and query our machine learning service to get that deployment, to get the scoring URL, et cetera. Okay. So as it's getting the deployment information, I'll explain a little bit about what we're going to do. So in order to set up this quality monitor, what you'll see down here is essentially we're going to enable quality monitoring, we're going to give it a threshold, and then we're going to give it a minimum number of records. So the threshold, right? It's when do we want a trigger to occur, right? So in this one, we were looking at the AUC value. If it falls below 0.7, we want it to trigger an alert, right? So our model is not performing the way that we expected. And you see I scrolled up here, it finished executing, so I'll just keep going through and executing the next cells. Like I said, if you're having trouble with the speed here, all the notebooks are documented, so everything I'm saying is, documented in this markdown. So go ahead and keep on executing the cells. Again, that's my subscription, the one we set up in the previous notebook. And then here's where I'm setting up my quality monitor that will trigger an alert if the performance drops below 70%. And then we set up the minimum number of records. So again, we're going to look at feedback data, right? So as you're telling the model, here was the correct prediction. We're going to look at the last 50 records to calculate our performance metrics. And then obviously for this to actually work, we need feedback data. So we've got some here. We're essentially going to simulate, not only are we simulating load on the model, in this case, we're simulating feedback data. So somebody that's come in and labeled some data for us. And then we're going to trigger this monitor to run. Now for what you'll see in this one and in the subsequent monitors, a lot of times these will run on their own. So we have it set on schedule. So every hour we'll check for fairness. Every 3 hours we'll check for drift. Through code, you can force it to execute, which is what we're doing here. And in this case, if you wanted to read through this, we've calculated kind of the performance, the data science metrics. You can see my area under the ROC curve is 0.66 here. My precision is 0.76, et cetera, et cetera. And you can read through this. If you wanted to, you can even plot this again, depending on, if you wanted to actually see this visually. All right, so that's the first one. We've got quality enabled. The next thing we'll do is we'll enable explainability. So explainability, one of the things you're seeing that we're doing here is we need to actually give it the training data, right? So when we get to actually try to explain a transaction, one of the things we're going to look at is the statistics around that, the training data, right? And you'll see this when we show it in the UI. But think, for example, if we're going to try to explain a transaction and say that these features had a certain weight, but if you change these values, it would lead to a different outcome. We need to know things like what the distribution of the values are, right? So if we move more towards kind of the medium of the values, or if we move away from it. So that's why we're giving it the training data. You don't need to. You can set these. We have notebooks separately where if for some reason you didn't want to give us training data, or you didn't want to push the training data to the cloud or the service, you can build these things outside and just give us kind of the information about the training data. Okay. So we've enabled explainability, and if you see here, this output is essentially showing me these are the predictions. I can take any one of these transaction IDs, essentially a prediction, and I can go have OpenScale explain it, which we'll see in a bit. All right, so we're done with that notebook. Come back here to your Git book. So at this point, we've got our model, we've subscribed to our model, we saw some operational characteristics. Now we've enabled quality and explainability. So let's actually see what that looks like. So going on to this next section here, if you go back to your OpenScale UI, and then just click on the top left where it says Watson OpenScale, and then click on the model monitors, now you see it looks a little bit different. So we have information about the quality of our model. In this case, it's at 67%, the value that we told OpenScale in our subscription that we care about. And we see this little trigger, this little alert flag. And it's telling us, hey, this model is not performing up to par for the quality monitor. So you can go ahead and click on that. You see again, we have that little icon. Again, it might be hard to see on your screens, it'll be easier, but you see here, this is the value. This was when we ran the quality monitor. It's performing below par. You can click on it if you want to, and then you get cool things like confusion matrices, etc. You can see, you know, these values over time. So great, now we understand a little bit more about our model. Now we understand the performance or the quality of the model. So go back to your Git book, and we're going to proceed to the next set of monitors. And the next set of monitors is kind of where it gets even more interesting. Now we're going to start looking at fairness. All right, so whether this is, you know, just because you want to build trust in AI, obviously, or maybe you're in a regulated industry and there's regulations around kind of like fair credit lending, things of that nature. You want to ensure your models are behaving in an unbiased way. That's where fairness comes in. So we're going to configure it. This time we're going to do it differently, right? So we saw how to do things programmatically using notebooks. This time we're going to show you how to configure a monitor using the UI. So what we'll do here is click on our model monitors inside of OpenScale. And you'd see that there's this option called Configure Monitors. Now these are the ones that we've already set up. So you saw me do quality, you saw me do explainability. Now we're going to click on Fairness. And then click the Begin button. And we're going to configure this model to start monitoring for fairness. First thing we have to do is we have to tell OpenScale, well, what's a favorable outcome? Think of this as what is a good prediction, right? In our case, our favorable outcome, a good prediction, is no risk, meaning the loan applicant is predicted to have no risk and hopefully they get a loan. And then an unfavorable outcome is risk. Click Next. And then the next thing that we're going to do is essentially tell the service which of these features do we want to monitor fairness against. Again, you know, some of these will be regulated features, so things like gender or sex and age. You know, those might be things that you, based on your industry, you know you have to monitor for those. And the OpenScale service will go inspect your training data and kind of tell you these are two possible features, which is what happened there. Or you can go select other features if you wanted to. I'll leave it at the sex and age features. Click Next. And what we're going to do is essentially now tell it, okay, so for each of these features, what's the minority and what's the majority? So think about it this way. For the sex or the gender feature, we want to make sure that in this case, maybe the minority group, the female, is receiving favorable outcomes at the same rate as males. So we'll set it up so that our reference group, in this case, is males, and our monitored group, the one that we're making sure there is no bias towards, is female. So leave those as is, and then click Next. And then we're going to set a threshold. So similar to how we had thresholds for quality, we'll set threshold for, you know, if the model starts to give favorable outcomes towards the majority group, or sorry, the protected group at a much lower rate than the majority group, we want to have an alert. We want the model, we want OpenScale to tell us there might be a bias or a fairness issue with this model. We're going to set it at 95. If you set it to 100, you're essentially saying that you expect both the male and female group to receive the same rate of favorable outcomes. Okay, so that was the gender one, or sex. We'll set this same thing up. This time we're going to do it for age. I'll do this fairly quickly, where our reference group, in this case, or our majority, is going to be, let's say, 26 to 75. And then our monitored group is going to be 18 to 25. So what we're doing in this case is, where before we were monitoring for fairness against gender, now we want to make sure that we're treating the younger population the same as, you know, everybody else, right? So make sure that folks that are 18 to 25 are hopefully getting favorable outcomes, or they're getting loans at the same rate as the rest of the population. So enter those values, click Add. I'm going to disable the ones that were created by default, and then click Next. And then like I did before, I'm going to set my threshold. In this case, I'm going to set it to 95. And then I'm going to set a sample size of 200. And again, this is all documented in the Git book. So I'm essentially at this step here. So this is where OpenScale is going to wait till it has 200 records, at least 200 records, before it evaluates for fairness. All right, so go ahead and save that. And once that's saved, we'll have configured fairness. The next thing we're going to do is configure drift, and I will speed up a little bit here. So what's drift? So drift is this notion that we want to make sure that the model is resilient. The way that we think about drift, or the things that we're going to monitor for, are when there is drift, either because the type of data that we're starting to get is similar to data that we struggled with initially, right? So if you think about this, it's, let's say for your training data, you didn't have good representation of the younger population. And you trained your model with that, right? So you had a very small number of records with a certain age group, right? You built your model, you deployed your model, you were happy with it. Now all of a sudden you see an influx of loan applicants that are in that younger population. If your model struggled with that data initially, the drop in accuracy is essentially going to tell you, we're starting to see a lot more of this data that we know we struggled with. We might see an estimated drop in accuracy because of that, and essentially trigger us that we need to gather some of this data and retrain the model. So that's this notion of drop in accuracy, and being able to use that for drift. The other one is data consistency, right? So when we trained our model, we had training data that was hopefully very representative of the kind of data the model was going to see. We don't know that that will always be the case, right? So being able to determine that there is a drop in data consistency is another form of drift that we're going to look at. So we're starting to see this data, and it doesn't look anything like the training data that you trained the model on. We'll see an alert when that starts to grow beyond a certain threshold. So that's what we want to set up. Go ahead and click Begin. Like I mentioned before, you have two options. You can either go and create this drift detection model on your own if you don't want to upload your training data. For us, for the lab, we're just going to select to have the drift detection model created by the service, so it has access to our training data. Click Next. We're going to set a threshold. So how much tolerance do we have? So we're okay with this model going with around 10% degradation in performance. If it starts to get beyond that, that's when we want to see an alert. Click Next. And then, like we've done for the other monitors, we're going to set a number of records that we want to see before we evaluate. And you can use the slider or just enter it. Go ahead and click Next and save. One quick note I will say is I expect this process of creating the drift detection model to take between 3 and 7 minutes. If you see it take longer than that as you're working through the lab, easy way, it's taken 15 minutes. Go ahead and click the edit button, save the configuration again. It'll kind of re-trigger that process to create the drift detection model. All right, so as that is happening, we're going to move on to the next step of the notebook. Sorry, the next step of the lab. And now that we've got the models, in a real environment, in a production environment, we actually expect to see, real-time data or predictions, scoring requests being sent to the model, so that we can see, so that we can exceed these thresholds that we set, right? So we need to see at least 200 payload records before we trigger a calculation of fairness. That would happen in reality in an actual production model. For the purposes of the lab, we're going to simulate that by just submitting 200 requests. So you see here the next step is we have a notebook that will submit requests to the model. So go back to Watson Studio, click on your project, and this time open the model scoring request notebook. As that's opening, again, I'll copy my machine learning service credentials. Make sure you click the pencil icon to actually, start the notebook or start the kernel so that you can execute the notebook, and then start executing the cells. As that first one's executing, drop in my machine learning service credentials, and then keep executing. A lot of these cells, you'll see it's very similar to what we did before. So getting the endpoint, getting the information about the deployed model, getting the endpoint is really what we care about so that we can submit the scoring request. And then we have a set of essentially sample loan applicants. It's actually a large file here, but we're going to select, in this case, 200 different ones at random. So we're going to select 200 different loan applicants at random and submit them to the model. So go ahead and execute that cell. And then once that's done, hopefully you'll see here, we've submitted 200 requests and we got 200 results. At this point, I don't really care about what the results were. I just want to know that we submitted the request so that I can go in, and the next thing I'll do is actually trigger the fairness check and the drift check. So let's go ahead and do that. So go back to OpenScale in the OpenScale UI. Click on the top left OpenScale naming here. Back to our familiar dashboard. Click on Monitor Models, and then click on your deployment. And you see a little bit of changes here, right? So before we had quality, now we had quality and we had performance and analytics. Now we have two new sections. We have fairness and we have drift. Now, as I mentioned before, in reality, you can have this model. It will go evaluate for fairness at a predefined interval. In our case, we're going to force it, and the way we force it is we tell it, go check fairness now. So go evaluate. If you're running this offline, if you essentially submitted those scoring requests, waited some time, came back, you might see that your OpenScale instance has already checked for fairness. All right. So as that's going, this might take a little bit of time. So what I'll do here is I'll actually flip over, and I've got another instance here that I've pre-configured. And if you see here, I ran this one yesterday. Same setup, same set of notebooks. You'd see here that now I have a trigger for fairness. So for the gender or the sex feature, I'm being told that we violated our threshold. So we set that threshold to 95%, and the model is performing at 93%. You can go ahead and click on that, and you get to, let me navigate to the right section of this notebook. All right. So if you get to this point, you'd see that we have some information about fairness, right? And this is where it gets really interesting, right? So this is telling us essentially we're giving out favorable outcomes to the female group 74% of the time. We're giving them out to the male group 79% of the time. If you calculated that rate, 74 over 79 should be 93. So now we'd get a trigger telling us this model is essentially biased. It is not treating the female group the same as it is treating the male group. There's a lot of different things you can do here. Let me just kind of take you through what's available. So one thing you'll see is we can go in here. We can see the payload plus perturb data. So this is actually something OpenScale does for you. It takes the payload that you sent. It also starts to flip the feature values, right? So we want to make sure that the reason that this prediction was, in this case, risk, was because specifically of the sex attribute, the gender attribute, right? Did they get a risk outcome because they were female or because they were female and had no checking? So what we do is we perturb the data, we submit that perturbed data to your model, and then we use that to calculate whether it's biased or not. If you didn't want to see that, you can just look at the payload without data perturbation, or we can even see just the training data. So kind of off the bat, you'd see that we have a lot more training data for the male group than we do the female group. Might be something for the data science or the developers teams to go remedy. And then the last thing we do is we actually build a shadow model. So if you clicked on the debiased radio button, so under the covers, we're going to go and create an unbiased model and create an endpoint for it. This is a model where we think that this model performs more, gives fairer outcomes to the population that the features that you determined were protected. So this one performs more unbiased or more fair relative female to male, right? So they both get 80% favorable outcomes. Obviously, it does have impacts on other features. So you'd see here that, by making this change, by having this debiased model, now a little bit less, or I've changed the way that I give favorable outcomes to the different age groups. And you can see that here. You can use this model if you wanted to. There's a scoring endpoint for it. You don't have to, but we do create it for you in OpenScale. The other thing I'll show you, so now we know that the model is biased. The last thing we want to look at is how do we have transparency, right? So how can we actually see why this model arrived to its predictions? And that's explainability. So if you click on View Transactions, for every record, right, every payload, every scoring request that's submitted, OpenScale can go and tell you, why did we get to that prediction? So here, you can click on any one of these. Let me just show you biased transactions. Click on Explain. And OpenScale will go and tell you, okay, for this prediction, with these values, it was a risk outcome. It was 54.05% towards risk, 45.95% towards no risk. But then it also gives you what were the features that contributed to that outcome. So in this case, they were determined to be risky more so because of the values for age. They have no checking. Their employment duration is 4 to 7, etc. So it's great insight. You can start to explain, yeah, this is why we arrived at the prediction. But moving beyond that, we're also going to see cases where we want to be able to explain, well, how do I change the outcome? So this is what we call contrastive explanations. So if you look up here on the top, we have a way to tell you these are the things that need to change, or the minimum number of changes you need to make to go from a risk to a no risk outcome. So if, some of these, you can't really change your age, but if you change the loan duration, that might help you go from a risk to a no risk. Conversely, there are things that doesn't matter if you did change them, you would still be classified as risk. So again, it's kind of not only explaining the prediction, but giving you that next level of insight around the prediction. All right, so that's fairness. Now we've seen a little bit of quality, we've seen throughput, we've seen analytics, and we've seen fairness. We can also see drift. And if you come back here, the model we were running live, you'd see I have my fairness. And this might be different for you, right? So we selected 200 records at random. So you may or may not see risk. If you don't, just submit another 200 and you'll start to see different values. All right, so the last thing I'll show you here is drift. So go back into your model and click on drift and then drop in accuracy. And then for any of these values, similar to what we did before, we're essentially going to give you 3 sets of data, right? So what transactions contributed to a drop in accuracy? So that initial bucket I mentioned earlier, things that look like transactions that we struggled with at training time. it's going to give you transactions that were responsible for drop in data consistency. So these might be records that, you know, don't look anything like the data that you trained with. And then there's some transactions that are kind of both. And then for each of these, you know, the insight that you're really getting is essentially a clustering, right? So it's going to tell you, you know, for the ones that had data consistency issues, or that we think there's data consistency issues, these are the features that are represented there, right? So you might go at that and look and say, I'm starting to get a lot more loan applications where, you know, it has this loan duration, this credit history, et cetera. So again, that's Drift. Feel free to explore that further. And then that is essentially the lab, right? So if you look at the skip book, there are a couple more sections here. So load historical data, payload analytics, these are all other things you can do with OpenScale, right? The whole notion of OpenScale is that you're monitoring this model at runtime. So you're getting more data, and it becomes more insightful, more meaningful as you get that data, right? So we have notebooks in here that will load more historical data for you. Let me just show you that real quick. So I had another deployment here that I'm clicking on. You can see here, you know, it's a lot more data that's in these graphs. Again, all generated data, but it kind of gives you a sense for the other things OpenScale can do. The other sections of the optional notebook, you can do payload analytics, you can build charts and visualizations, and then you can build these application monitors. So application monitors is another very interesting subject. It's, you know, me as a business, if I'm asking for this model to be created, I don't necessarily care about, you know, what the accuracy is or the specific number. I care about what the impact of that model is to my business KPIs. So for this example, it's, you know, how much credit, how much money am I actually loaning? How many loans am I approving? And, you know, how does that affect my business? So we have a section here around application monitors and setting up application monitors. So that is essentially the lab, right? And that's pretty much everything. Go through the optional sections. I do want to thank everybody for attending. Hopefully, you know, you went through that with me here and you found it useful. I will say that if you've gone through the lab, I'm going to put up one last link here. If you've gone through the lab, you're eligible for a badge. I have the link there. Go out to the link, claim your badge. You've successfully completed this monitoring and model management lab. So definitely do that. I'll also say that we have other resources and challenges if you want to continue learning about machine learning and different capabilities. Please feel free to use those. And we'll be around in the digital conference, I believe, for another half hour. So if you have questions, you know, find us on Slack. The replays will be available. And again, thank you. I hope you enjoyed this. I hope you enjoyed the digital conference. Thank you.